Okay, so here is an in-class example. This is an added problem. It's about center of mass, and it's kind of one final review of this material, how to find center of mass. Okay, because we're finishing up the chapter again, we're skipping some stuff. But before the exam and before moving to the next chapter, I wanted to review this one more time. So I do strongly suggest click on the files on the Canvas page and for class 32 and have this document with you, and then try to do it your own, get your answers, and then check this video afterwards. Okay, don't look at the solution beforehand, otherwise you will feel like you learned it and you understand it, but it may not be very clear when you try to do it, and that's what happens in the exam, and then you're struggling more. Okay, okay, assuming that you checked it, so I'm going to go through the solution with you. So consider the shape below. And this is also part one. There are two parts. Make sure the axes are right in between, like you see where the origin is. So the only difference between part one and part two is where the origin. So check that. This is the one I'm doing right now. And so consider the shape below, formed by welding plates of aluminum together. And each plate is of size L, wide by L high. Okay, and using the table below, find the x-coordinates for the center of mass. Be sure to use the given axes and get your answer checked when you're done. So where the origin is will define where the center of mass coordinate is. So it's gonna depend on that. So it's very important that we use that. So that's why we put a red coordinate system so that you can definitely see it. And we will do the same thing for y coordinate of center of mass. So first of all, before filling out the table, I want to write down what my equation is. X center of mass is sum of mi xi's, right, and divided by the total mass. Same way we can write the y coordinate, y center of mass coordinate as well. It is from mi yi multiplied divided by the total mass. And once again, I goes from 1 to number of particles, and we can even write how many particles we have. You can see that there are 5 pieces, so that little n is going to be simply 5. So I'm just going to complete my equations. I goes from 1 to 5 for x as well, and then we're going to write down what these are. So the table helps because you can see that this is mixi, for example, and this is going to be the total right here. So we just need to put this in there, right? And then the total mass is going to come at the bottom, so you can simply find out what the values are. So that's the plan. But to get to mixi's, let's just find out what the xi's and yi's are. Okay, just gonna press that. So let's focus on the figure now. Let's do the x-axis first, and for that one I have 5 pieces. Again, for the center of mass, the part 1 split into known shapes, right, symmetric geometrical shapes, and we already have 5 squares, so we're going to do 5 pieces. And then you locate the center of mass of each piece. Those are the geometrical centers. So this one is going to be right at the center, so you can do diagonal to find that, right, or you can just simply show where it is. And also I'm going to change this, and so we can just put it that at the center, and this one is going to be at the center. Third one is also at the center, fourth one, and the fifth one. So those are the geometric centers right at the centers of the squares. Okay, and next we are going to find out where those locations are. So we are focusing on the x-axis first, and that means let's draw our line. So 1 is right there. Now read this point right here, and you know that the square has L by L. It's very important to note that where the origin is, because you're measuring your distances from the origin. So for example, from here to there is x1. Okay, if the square is L, this is going to be half of that. So x1, again, piece 1, xi, I'm writing L over 2 because it's a half size, right? Again, once again, this is L, okay? Same thing happens for number 2, right? And same thing happens for number 3 as well. So let's just put half L for each of those. And the fourth one is gonna have a different one. So it's gonna be right here. We already know that from here to there is L, and we need to add half of that. So it's gonna be 3 halves, right? And the fifth one right there, so we can do the similar thing, 1L, 2L. That's something that I didn't know I could do. 2L and 2.5, right? I mean, 5 halves. Okay, so those are xi's, and then we're going to just like, since each piece, we're assuming it's homogeneous, and each piece have the same size, that means they will have the same mass. We can just call it each piece to have mass m. So we can write down what is mi, xi, by multiplying all these xi's with m. So the first one is going to be ml over 2, second one is the same, third one is the same, fourth one is 3 ml over 2, and the fifth one is 5 ml over 2. Okay, then you can add these up. They all divide by 2, and then if you add up the coefficients of mLs, so you have 3 m's, right? So that 3 plus 3 plus 5, and you get 11 ml divided by 2. And you don't really need the totals of xi's and yi's because they don't mean anything. So we can cross these out. And now the top part here, to find the center of mass of X position, I'm just gonna get 11 ml over 2. That's what I've done. I added up. And the total mass, since I had 5 mass, I have 5m. And that will give you 11 m's are gonna go away, 11l over 10, right? Or 1.1 L. So that's your answer for the X center of mass. So we're going to do the similar thing now for the Y. And I'm going to get rid of some of the X stuff here. So we're focusing on the Y-axis this time, and we're going to do the similar thing. Let's just draw lines along the Y direction. So for the first one from the center, it's going to be right there. First of all, it is below the y-axis, so this is the point I'm focusing. So if I draw my y1 position vector, it would be downward like that. And since it's negative, first of all, and half the size of the cube or the square, it is L over 2. And it is negative L over 2. Okay, and the second one, again, I'm drawing a line to the y-axis. That is positive, right? But it is still half L. And the third one, so you're doing again from here, from the origin to up there, this is L, and one more half of L becomes 3 halves. And as you can see, 4 and 3 have the same distance, so this is also going to be 3 halves. But the fifth one is going to be right there, and this was simply right here, it's L. Okay, so put these down as well and multiply by mass. So we're going to do the similar thing. So this is going to be multiplied by m, each of them. So I'm going to do that, negative ml over 2, positive ml over 2. You can see that these two will cancel out, 3 ml over 2, and another 3 ml over 2, and 2, not 2, ml. We're going to add these up once more. And again, the first two will cancel out. The next two is gonna make 6 ml over 2. That is 3 ml. And you have one more piece, which is ml. When you add them up, you get 4 ml. And that is the answer to go at the top of this y center of mass equation. That's the sum of mi, yi, and that is 4ml. Divide by the total mass, which is 5m. We can also cancel m's and make the denominator 10, so we can do a fraction like that. So it becomes 8l over 10, multiplying both sides, top and bottom, with 2, and that gives you 0.8l. And that is the center of mass location for the y-axis.